The Orlan-10 represents one of the most important milestones in Russia's modern drone development. Introduced in the early 2010s, this unmanned aerial vehicle was designed to fill a critical gap in battlefield awareness by providing real-time reconnaissance, surveillance, and electronic intelligence capabilities. Unlike earlier Soviet-era unmanned projects, which were limited by technology and cost, the Orlan-10 focused on simplicity, endurance, and adaptability. The drone's lightweight airframe allows it to remain airborne for extended periods, making it suitable for long-duration observation missions. It is launched using a catapult system, eliminating the need for prepared runways. This design choice reflects a shift in Russian doctrine toward flexible and rapidly deployable systems. One of the defining features of the Orlan-10 is its modular payload system. Depending on mission requirements, it can carry optical cameras, infrared sensors, and electronic warfare equipment. This versatility enables it to operate in multiple roles, from reconnaissance to signal interception. The drone's data link system allows information to be transmitted back to ground stations in near real time, improving situational awareness. Historically, the Orlan-10 symbolizes Russia's transition from reliance on manned reconnaissance aircraft to cost-effective unmanned platforms. It demonstrated how modern conflicts increasingly depend on information dominance rather than sheer firepower. While not technologically advanced by Western standards, its widespread deployment shows how mass-produced drones can shape modern warfare. In the broader evolution of UAV technology, the Orlan-10 stands as a practical workhorse, less about cutting-edge innovation and more about reliability, scalability, and integration into combined arms operations. Its continued presence highlights how endurance and numbers can sometimes outweigh sophistication. The four-post drone marks a significant step in Russia's long-range unmanned surveillance capabilities. Originally based on foreign design concepts, the system was adapted and developed to meet domestic operational requirements. Its introduction signaled Russia's recognition of the importance of persistent aerial surveillance over large areas. Unlike smaller tactical drones, the four-post is designed for extended missions covering vast distances. Its aerodynamic design and powerful propulsion system allow it to operate at higher altitudes and for longer durations. This makes it particularly suitable for border monitoring, maritime observation, and strategic reconnaissance. The Drone-S sensor suite includes high-resolution cameras and advanced optics capable of operating in various environmental conditions. This reflects a shift toward all-weather day and night intelligence gathering. The four-post also emphasizes data integration, enabling collected information to support command-level decision-making rather than just frontline awareness. From a historical perspective, the four-post illustrates how Russia adapted international UAV concepts to accelerate its own drone programs. Rather than starting from scratch, engineers focused on modification and localization. This approach shortened development cycles and allowed faster deployment. In the evolution of Russian drones, the four-post represents a bridge between early reconnaissance UAVs and more sophisticated systems. It helped establish operational experience with long-endurance unmanned platforms and laid the groundwork for future domestic designs. The Aileron-3 drone showcases Russia's focus on small, tactical, unmanned systems designed for short-range intelligence gathering. Compact and lightweight, it was developed for rapid deployment and ease of use. Its design philosophy prioritizes portability, making it suitable for field operations where speed and discretion are essential. The drone's electric propulsion system allows for quieter flight, reducing detection. Its compact airframe supports hand or simple launcher deployment, emphasizing flexibility. The Aileron-3 primarily serves as an observation platform, carrying cameras optimized for reconnaissance missions. Technologically, the Aileron-3 demonstrates how miniaturization transformed unmanned aviation. Compared to larger UAVs, it trades endurance for mobility. This reflects a broader trend in drone development where layered systems, small, medium, and large UAVs, work together to provide comprehensive situational awareness. Historically, systems like the Aileron 3 highlight how unmanned technology became accessible at lower levels of command. Instead of centralized surveillance assets, smaller units could access aerial intelligence directly. This decentralization represents a major shift in military information flow. Within the evolution of Russian UAVs, the Aileron 3 occupies an important niche. It shows how even simple platforms can significantly enhance awareness and decision-making in modern conflicts. The Tachyon UAV represents Russia's effort to enhance frontline situational awareness with a lightweight, rapidly deployable reconnaissance drone. Developed for tactical-level operations, the Tachyon bridges the gap between hand-launched micro-drones and larger battalion-level UAV systems. Introduced during the 2010s, the Tachyon was designed with modularity and portability in mind. Its compact airframe allows it to be transported easily by ground units, making it ideal for reconnaissance missions in diverse environments. Unlike larger UAV systems that require dedicated crews and complex infrastructure, the Tachyon emphasizes field simplicity. The drone features an electric propulsion system, reducing noise and improving operational discretion. This quiet profile reflects a broader trend in UAV development, where stealth and reduced acoustic signature are increasingly prioritized. Its relatively short wingspan and streamlined fuselage support stable flight at low to medium altitudes. Technologically, the Tachyon carries optical and thermal imaging systems, enabling day and night observation. The integration of digital data transmission systems allows real-time intelligence sharing with command units. This reflects the growing importance of network-centric warfare concepts, where data flows rapidly between sensors and decision-makers. From a developmental perspective, the Tachyon demonstrates Russia's adaptation to modern combat environments, where rapid reconnaissance can influence operational tempo. Rather than relying solely on centralized surveillance platforms, systems like the Tachyon empower smaller units with aerial observation capabilities. In the broader evolution of Russian UAV programs, the Tachyon highlights the diversification of drone roles. It is not designed for long endurance or strategic surveillance, but instead for immediate, localized intelligence gathering. This layered drone ecosystem, micro, tactical, and operational, reflects a mature approach to unmanned aviation development. Ultimately, the Tachyon symbolizes the growing accessibility of UAV technology at lower command levels, reinforcing how modern military structures increasingly depend on distributed information networks. The Zala 421-16E represents one of Russia's advancements in compact reconnaissance UAV systems. Developed by Zala Aero, this drone reflects the increasing role of private defense companies in expanding unmanned aviation technologies. Designed for tactical intelligence missions, the 421-16E features a lightweight composite airframe optimized for endurance and portability. Its aerodynamic shape supports extended flight duration compared to earlier small drones. The system is typically deployed via launcher systems, reinforcing its suitability for field operations. One of the defining characteristics of the Zala 421-16E is its advanced sensor integration. Equipped with stabilized optical and infrared payloads, it provides enhanced observation capabilities under varying environmental conditions. The stabilization technology ensures clearer imagery even during turbulent flight conditions. The drone also reflects the integration of digital command and control networks. Real-time data streaming allows collected intelligence to be rapidly analyzed and shared. This highlights a shift toward more connected battlefield ecosystems, where drones act as nodes within larger information systems. Historically, the Zala series marks a period when Russia expanded domestic UAV research and production. The involvement of specialized aerospace firms indicates a strategic push to diversify drone capabilities beyond traditional state manufacturers. Within the broader evolution of Russian military drones, the Zala 421-16E showcases the refinement of small UAV systems. Compared to earlier models, it emphasizes improved optics, endurance, and communications reliability. These enhancements align with global trends in drone miniaturization and sensor advancement. As unmanned systems continue to evolve, platforms like the Zala 421-16E demonstrate how technological progress is often incremental, building upon proven frameworks while integrating modern electronics and materials.